I think we would all agree that using protection is a great idea, and we can apply protection in the form of protection profiles to zones on our Palo Alto firewall. In this nugget, I'll walk you through how to do that, and then we'll verify that it's working. Let's begin. Once we connect a firewall to the internet, in my experience, there's only two types of firewalls. One, a firewall that's been attacked and beat up and had all kinds of crap thrown at it. And secondly, a firewall that will have a whole bunch of stuff coming its way. And that's because the internet is a big place, and this guy right here isn't alone. There's millions of devices and individuals who are creating and launching attacks meant to compromise our security. And through their attacks, they might get unauthorized access to either see or modify data. And some attackers don't want to actually steal our data, but they want to disrupt services with denial of service type attacks. And some of the attacks that may be launched include flooding, where the attacker is sending in traffic, for example, maybe to this server at such a high rate that the server simply can't keep up with it. And we're not talking just about quantity with the flood. We could also do SYN flood attacks, where we're tying up resources, doing a three-way handshake or starting a three-way handshake with the server and then never showing up for the completion of that three-way handshake, with the intent there of tying up resources on this server. So that's a classic TCP SYN flood attack. And floods could also be done by simply bombarding with other protocols as well, including UDP and ICMP and so forth. Attackers may want to be doing reconnaissance. They're trying to find out, for example, what devices live on a network or what services, what well-known ports are open and available on a device. And there's also packet-based attacks, either manipulating the individual packets or misusing or abusing the protocols with the intent of causing harm at some level to the devices that they're attacking, which could be stealing or manipulation of data or disruption of services. And the great news is this: if we want to, we can set up zone protection profiles on the Palo Alto firewall and then apply those profiles to help mitigate against these types of malicious behavior. And we can apply those profiles to zones. That's why they're called zone protection profiles. So if we have 5 or 6 interfaces that are connected to the outside untrusted world, and they're all members of the outside zone, we can simply apply the profile to the zone, and then we'll get the protection of that zone protection profile for any interfaces that are associated with that zone. And there's 2 basic steps in setting up a zone protection profile. Number 1, we are going to create the profile. And then step number 2, we are going to apply the profile to a zone. And that's it. So let's do a demonstration of exactly that. So here in the GUI, to create a zone protection profile, we're going to go to the Network tab up here, second from the top right. And with the Network tab selected, over on the left, near the bottom under Network Profiles, we are going to select Zone Protection. And I've got a question for you. What would we do to create a new zone protection profile? And if you're saying, Keith, we got this, it's click on Add. You'd be absolutely correct. So we'll click on Add, which is near the bottom, and we'll give it a name. Let's call it our ZP profile. And for a description, let's say that we're going to apply this to the outside. And then we have 3 major tabs: flood protection, reconnaissance protection, and packet-based attack protection. And lots of options in each of these. So let's start off with flood protection. If we want to protect against the various types of flooding, we simply put a check in the respective check boxes. So here's SYN flood, here's ICMP, ICMP version 6, other IP, and UDP. And for each of these, we can set the alert, activate, and maximum levels. So when the alert threshold is reached, it'll create an alert. When we reach the activate threshold, it'll go ahead and implement whatever action we have here. For SYN-based, we have actions of random early drop and TCP SYN cookies. And when the maximum is reached, it doesn't allow anything above that to go through the firewall. So let's take a look at our actions. So the actions we have are random early drop and SYN cookies. So with random early drop, once it's been activated, individual SYN packets are going to be dropped randomly, hence the term, to restrict or lower the traffic flow as long as it's above that limit that's set right there. Currently it's set to 10,000. The other option we have for SYN-based flooding is the TCP SYN cookies. And TCP SYN cookies are awesome because what they do is they allow the firewall to take, for example, the beginning of a 3-way handshake, a TCP SYN request, send an acknowledgement, but not have to maintain state or remember that 3-way handshake that's in process. And it does that by manipulating the TCP header that it sent back to the client. So if it's a valid client and the final 3-way handshake acknowledgement comes in, the firewall can say, oh yeah, I recognize that based on the header you're sending me, and it can complete the 3-way handshake. And for bogus 3-way handshakes that have been started by clients, the firewall doesn't have to keep remembering about that half-formed session, so it's going to lower the impact on the firewall. We're also protecting the back-end resource, like the server, that never has to receive these half-formed sessions because the firewall stepped in and did the heavy lifting on behalf of that server. And once enabled, it has some recommended values here for the alert, activate, and maximum. And by default, setting the activate to 0 means that we're doing TCP SYN cookies right out of the gate for every single TCP session. But we can change these numbers as we'd like to. So we might want to find what, for example, is our baseline of what normal looks like. And then based on that baseline, we might want to do alerts if it's 10% higher than the baseline. Because having a baseline of what normal looks like is really important in setting any of these, because we don't want to start clipping or limiting traffic for valid users just by throwing in a number blindly. So using a baseline would be a great idea. And then for the others, ICMP and other IP and UDP and ICMP version 6, because there's no TCP, there's no three-way handshakes involved in those, the activate is simply going to be the random dropping of that traffic once it reaches the threshold. So the next tab over is reconnaissance protection. So if somebody's doing a TCP port scan, for example, they're looking for hundreds or thousands of potential ports that might be open on a host, and we want the firewall to identify that and stop it, we can enable a TCP port scan protection. Or if somebody is trying to find out what hosts are available on the network by doing a scan of the network that way, using Nmap or ZenMap, we can have the firewall identify that and then stop that from proceeding. And there's also an option for a UDP port scan. So the interval over here is also adjustable, as well as the threshold, the number of events. So for each of these, it's looking for 100 events within 2 seconds for the TCP port scan and within 10 seconds for the host sweep, respectively. And I want to remind you that because this is a zone protection profile, this is an aggregate of all this activity that's happening across any interfaces that are associated with the zone that we apply this profile to. The other thing I'd like to talk to you about is regarding the action we can set up if the thresholds are exceeded. So by default, we have alert. But if we wanted to, we have 3 other options besides alert. We have allow, which simply allows it to happen. We have alert, which is the default here, so we can be notified that it's happening. We have the option of block. And if we select the option of block, it's going to block traffic between the source and destination addresses. Effectively, it stops the attack from happening any further once that threshold is reached. And then we have block IP, which is interesting. I'm going to show you block IP in a little bit more detail. With block IP, we have additional options. We can say we want to track this based on the source IP address, maybe the attacker on the internet, or based on source and destination. So it's a specific attacker going to a specific address that we want to block. We also have the option of how long we want to block them. It's like a timeout for a child. It's like, okay, we saw this activity. We are not letting traffic between these 2 addresses or based on the source address, based on our previous choice. Let's just say from the source address right here. And we can say it's going to be for 600 seconds, which is 10 minutes. So effectively, once the threshold is triggered and we have the action of block IP based on source, this attacker, his source IP address, he is out of luck for 10 minutes. So I wanted to show you those 4 options. I'm going to go ahead and leave it on the default of alert. And the last tab on the right here is packet-based attack protection. There's just a boatload of options here for IP, TCP, ICMP, IPv6, and ICMP for IPv6. So as an example, let's go ahead and grab ICMP drop, and let's drop ICMP large packets if they're greater than 1024 bytes in size, 1K. So we'll click on OK here, and now we've got this our zone protection profile, and we're going to apply this to any zones that are facing the untrusted networks, for example, the outside. So to apply this, we'll go to Zones, and we'll select the zone we want to apply this to. We're going to select the outside zone. And now that we're looking at the properties for the outside zone, we have this option down here near the bottom for Zone Protection Profile. We only have one. It's the one we just created. So from the drop-down, we'll select that, and then we'll click on OK. And we can see right here that for the outside zone, it now has a Zone Protection Profile applied to it. Now, we haven't committed this yet, because what I want to do before we hit commit, I want to go ahead and test just to verify that ICMP larger than 1024 currently is being allowed through the firewall. So here at Bob's computer, let's go ahead and borrow his machine for a minute. Let's do a ping, and we'll ping with a packet size that's larger than 1024 to verify it works. Now, the outbound ping shouldn't be an issue, but the reply, once we apply the zone protection profile, and because that traffic is coming in on the outside zone, the reply, because it's going to be greater than 1024, that should stop the reply from making it back into Bob. So we'll test it first without the zone profile applied, and then we'll apply it and try it again. So let's bring in Bob's PC. Here it is. I just want to verify real quick that we're on the right machine. So we'll bring up a command prompt, and we'll do an IP config. Sure enough, 10.1.1.25 with the default gateway pointing to our Palo Alto firewall. And let's do a ping, and let's press enter for the help here. And what I'd like to do is do a ping, and we'll use the -L for size. And then we'll say, let's say 2000. And let's go out to 8.8.8.8, and we'll press enter. All right, so thanks to Google and one of their DNS servers, they're able to reply to us with this ping packet. It's also confirming for us right here that we're sending a 2000 byte ping. So let's go back to the Palo Alto firewall, and let's commit our changes to create the zone profile and have it applied to the outside zone. So to commit this, we'll click on the commit icon, and we'll confirm that. And let's just wait just a moment and make sure it goes through before we try the ping again. Excellent. So we'll close that, and let's go back to Bob's computer. Back at Bob's computer, we'll go ahead and press the up arrow, and we'll do that ping one more time. And that is now failing. And also what I like to do is just to confirm that stuff is really working like it should, let's go ahead and do a ping with a smaller payload just to verify that ping really is still working. So I'm going to do a Control-C so I don't have to wait for all those to time out. And let's go ahead and do a ping. Let's do a payload of 1000. And with that, well, we could get out of packet capture and verify, but what I think is happening here is that we're doing a payload of 1000 and there's still some overhead for the IP packet. For example, the IP header itself is taking up some space. So let me trim that back just a little bit. Let's go to 900 for the payload. And there we go, much better. And that's making it through because the actual packet being sent is now less than 1024. In this nugget, we created and applied a zone protection profile and then verified it worked on the Palo Alto firewall. Hey, I appreciate you joining me for this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.